So today we are working on 15A, which is solving equations with variables on both sides. This is day number 3. The main difference is we're now going to be working with rational numbers. Our content objective is students will be able to solve equations that have variables on both sides of the equation and check their solutions. Language objective is students will be able to state mathematically the properties that are being used to solve these equations. Why am I learning this? Well, it's important for real life problems like finding out what cell phone plan is a better deal. So quick, some background knowledge. All I wanted you to see from this slide is, remember, if we have variables on both sides, we either move the variable to the left or to the right. It really doesn't matter. You're going to get the same answer. There are some cases where moving it to one side might be a better choice just because it's less step, but there's no right or wrong way of doing that. Here, just quickly showing you what we would do to solve if we had variables on both sides and how we would justify each thing. But one thing that I also want you to remember is, remember, if we have a false statement, it is no solution. And we prove that by saying the variables eliminate on both sides, like demonstrated here, and that we have a false statement. So remember that. And the other case was when we solved and we justified what is it going to look like if we have infinitely many solutions. Well, you need to check that the variables eliminate like it does here. And you also have to check that there's a true statement. So we got to make sure we have those two things. On that note, we're just going to go ahead and get started for this very first example here. I still want you to go over the same routine. Can I distribute? Can I combine like terms? Can I move the variable to one side? That's going to be the first thing that I can do. So I'm going to go ahead and subtract. I'm going to go ahead and move it over to the left. But again, to clarify, it doesn't always have to be moved to the left. In certain cases, you might want to move it to the right. So again, there's no right or wrong direction to move it. For here, I'm going to go ahead and subtract it to move it to the left. Here I'm left with negative 6/10 x. Everything else is brought down. At this point, I'm going to eliminate my constant. I'm going to subtract 9 from both sides, leaving me with 6/10 x equals negative 4 8/10. Please make sure you're very careful with the signs, because this is where a lot of students are going to forget the negatives and their answer is going to be thrown off. Last but not least, we're going to get rid of our coefficient by dividing both sides by negative 6/10. This is going to cancel out, leaving me with x equals a positive. You can think of these negatives as canceling each other out, and that's what gives you a positive 8. But you're not done. You always have to check. So I'm going to go ahead and rewrite this entire problem here with parentheses in for replacing the variables. And then I'm going to go ahead and plug in my 8 in both cases. I'm going to simplify. This is going to be 5/6 plus 9 equals 1 3/10 times 8 gives me 10 4/10 plus 4 200. 4 2/10. So here we're going to simplify what we have on both sides, and we do end up with 14 6/10 equals 14 6/10. Since this is a true statement, I know my answer is correct, and I would say that x equals 8. I noticed some of my students, they kind of forget when they check their work, they think, oh, true statement, infinitely many solutions. Be very careful not to do that. We do have a solution here. We were just checking it to make sure it worked. So keep that in mind. So here for number 2, I would like you to go ahead and pause the video and try this one by yourself, because the steps are the same. Nothing's changed, except now instead of working with whole numbers, we're going to be working with fractions and decimals. So go ahead and pause the video and try it on your own. Okay, so now let's check our work to see how well we did. So first, can I distribute? No. Can I combine like terms? No. Can I move the variable to one side? Here, I would have to. So again, I'm going to move it to the left. I don't have to. I can move it to the right if I want to, but just to keep things consistent, that's what I'm going to do here. I'm going to add 2n to both sides, leaving me with 1/3 n minus 1/3 equals negative 3/2. Okay, so what I did here was negative 1 1/2, I converted to an improper fraction, if you're wondering how I got negative 3/2 here. So now what am I going to do? Well, can I get rid of a constant? The answer is yes. So I'm going to go ahead and do the opposite of subtracting 1/3. So I'm going to go ahead and add 1/3 to both sides. which is going to leave me with 1/3 equals, here, when I combine these together, it's going to be -7/6. Okay, so at this point, I need to get rid of my coefficient. This does mean 1/3 times n. And if you ever do forget, you can kind of remind yourself by putting a multiplication symbol right in between to remind yourself, hey, it is multiplication. So I'm going to go ahead and do the inverse of multiplication by dividing both sides by 1/3. And my final answer would be n equals -7/2. But of course, we're going to have to check our work. I'm going to suggest that you, as you are rewriting this over here, that you turn your mixed numbers into improper fractions so you don't have to take an extra step. If I did that, I would have a -5/3 replacing the -1 2/3 and -3/2 replacing my -1 1/2. So now I'm just going to go ahead and plug my answer into where the variables were in the parentheses and simplify. I would be left with 35/6 minus 1/3 equals -3/2 plus 7. So here I got 35/6 by multiplying these two numbers together. And after multiplying these two numbers, the two cancel each other out, and that's how I got 7. After simplifying both sides, I would end up with 33/6 equals 11/2. At first sight, it may look as though that my answer is incorrect because it doesn't look like a true statement. But if you take it one step further and go ahead and reduce this fraction by 3, you do end up with 11/2 equal 11/2. So therefore, n does equal -7/2. Okay, so for number 3, I'm going to go ahead and have you try this one by yourself as well. So go ahead and pause the video. Another thing that I want you to do, though, instead of just checking your work when you're done, is I also want you to justify every single step that you do. Okay, so now let's go back and see how you did. So first things first, I'm going to go through my normal steps. Can I distribute? No. Can I combine like terms? Yes. So what I'm going to do here is I want you to realize I could combine two things. I can combine the variables together, but I also can combine the constants together. So notice, since I already circled these two terms to combine the variables together, I don't want to circle the constants either because it's going to appear as though I'm trying to combine everything together. So I'm going to go ahead and box the constants so that I know the difference between the two. So once I do that, I'm going to end up with p minus 5/2. So look again, notice what I did here. I converted -2 1/2 into an improper fraction. Here, when I combine the p's together, I'm left with 1p. Combining the constants together, I get left with -5/2. At this step, I'm going to justify it by saying that I combined like terms in order to get this step. Now, at this step, some students may even be able to tell me what the answer is right now, but I do want you to finish all the steps. So here, we're going to go ahead and move our variable over. In this case, we're going to move it to the left, but again, you can move it to the right as well. So here, I'm going to subtract p from both sides, which leaves me with -5/2 equals -5/2. At this point, I'm left with a true statement, which means, oops, so sorry, I almost forgot. Since I subtracted p from both sides, I was using the subtraction property of equality. So here, since it's in the form of a equals a, which is my true statement, I'm going to say that the answer is infinitely many solutions. But again, to check your work to prove that it is infinitely many solutions, I want to check that I did have variables eliminate, which I have right here. So from now on, I want you to even actually identify where it's happening so that you can actually check and not just write the words down, because I noticed some of my students are. And then here is where I have my true statement. So I do want you identifying those pieces and not just simply writing it down. So once again, you want to mention that the variables eliminate and that you have a true statement. Okay, so hopefully you got that one right. So now moving on to example number 4. Once again, go ahead and pause the video, try the problem, and justify each step that you do. Okay, so we're back. Again, we're just going to go through the normal steps. Can I distribute? In this case, the answer is yes. So I'm going to go ahead and distribute the 2 7/10 to both terms, which is going to leave me with this. I'm just going to bring it straight down. Nothing happened to it. But these values are going to change to 1 800 minus 6 4800 x How did I get this step? Well, let's look above. I distributed, so that's my justification using this distributive property. Now, can I combine like terms? The answer is no. So moving on, should I move the variable to one side? Definitely, because we do have variables on both sides. So in this case, I am going to add 6 and 4800 to move it to the left, which leaves me with 5 and 2800 x plus 2 and 136 hundredths equals 1 and 800. So again, I just brought it down. How did I get this step? Since I added 6 and 4800 x to both sides, I'm going to go ahead and say I used the addition property of equality. Now I'm going to get rid of my constant by subtracting 2 and 136 hundredths, thousandths, not hundredths, to both sides, which is going to leave me with 5 and 28 hundredths x equals negative 1 and 56 thousandths. So how did I get this step? Since I subtracted 2 and 136 thousandths from both sides, I use a subtraction property of equality. And last but not least, I need to get rid of my coefficient. And again, just a friendly reminder, this does mean 5 and 28 hundredths times x. Let's make that a different color, times x. So the inverse of that would be to divide both sides by 5 and 28 hundredths. So I'm going to go ahead and do that. And my answer is going to be x equals negative 2/10. And how did I get this final step? Well, I divided by 5 and 28 hundredths from both sides. So that is my justification. So there you have it. Now, let's just go ahead and move on to our next problem. It's going to be our first word problem. Okay, we're going to take it step by step. We're going to read it once over, and then we're going to go back and reread and find some of the important information from this word problem. So it says here, container A has 200 liters of water and is being filled at a rate of 6 liters per minute. Container B has 500 liters of water and is being drained at 6 liters per minute. How many minutes x will it take for the two containers to have the same amount of water? So what am I going to do first? Well, I'm going to look at container A. It has 200 liters of water, so I think that's important because that's how much it has right now. So I'm going to go ahead and write 200 liters, but it's being filled. Okay, so if a container is being filled, I am adding more water to it. So I'm going to go ahead and put add. Since it's being filled at a rate of 6 liters per minute, okay, since they're asking me to use x as minutes, I'm going to do 6 times x, because depending on how many minutes goes by will determine how many water is being added, since that is the rate. So I'm going to put 6x. And then container B has 500 liters, so that's how much it starts with. I'm going to write that there. It's being drained. Since it's being drained, we are losing water, so water is being subtracted. So I'm going to go ahead and subtract. And 6 liters per minute, that is my rate. So every single minute, 6 liters is being drained. So I'm going to go ahead and put that as 6x. Since they are asking me when are both containers going to have the same amount, I'm looking to see when they are going to be equal. So I'm going to go ahead and set them equal to each other. And there you have an equation. So all you need to do is solve. Can I distribute here? Nope. Can I combine like terms? Nope. Can I or should I move the variable to one side? Yes. I'm going to go ahead and move it to the left by adding 6x to both sides, which is going to leave me with 200 plus 12x equals 500. Now I'm going to check to see if I can get rid of a constant. I can, so I'm going to go ahead and subtract 200 from both sides, which is going to leave me with 12x equals 300. And last but not least, I'm going to get rid of my coefficient by dividing both sides by 12, and I get x equals 25 minutes. But you have to be very careful. The question was, how long will it take? So you don't want to say x equals, because that's not the question. In fact, the question was, how long would it take? So to answer in a complete sentence, I would say it will take 25 minutes before both containers have the same amount of water. So hopefully looking at this word problem and taking it step by step, you realize it wasn't that difficult at all. So let's look at another example. So here for number 6, it says a 12-inch candle and a 22.5-inch candle are lit at 6 p.m. The 12-inch candle burns 1/2 of an inch every hour. The 22.5-inch candle burns 2 inches every hour. At what time will the two candles be the same height? Let X represent the number of hours. So they are asking me when are they going to be the same height, and they do want us to use X as a variable. So here, first things first, let's collect something that we know about the first candle. We know that it's 12 inches, okay? And so I'm going to go ahead and write 12 because that's how much it's starting with. If it's burning, the length of the candle is being lost, meaning it's getting shorter. So I'm going to be subtracting since it's burning. If it's burning in 1/2 an inch every hour, okay, depending on how many hours go by, I'm going to have to multiply that by 1/2 to figure out how much is burned altogether. So that's going to be minus 1/2 X, since X is being used to represent the number of hours. Now let's look at the other candle. It's 22.5 inches, so I'm going to go ahead and start with that. If the candle is burning, it's losing its height, so we're going to subtract. If it's losing 2 inches every hour, that's the rate. So every hour, it's losing 2 inches more. So I'm going to go ahead and do 2 times X, which is going to represent the number of hours. Since they are asking me when they're going to be the same height, I'm going to go ahead and put equals. Okay, so now I have an equation. Can I distribute? The answer is no. Can I combine like terms? Still no. Should I move the variable to one side? The answer is yes. So I've been stressing to you that we normally move it to the left, but I kept also mentioning that it doesn't always have to be to the left. You can go either way. So here, to prove my point, let's go ahead and practice moving it to the right as well. So here I'm going to add a 1/2 to both sides. Notice I did turn the fraction 1/2 into a decimal because I figured it would be easier to do that here. I'm left with 12 equals 22.5 minus 1.5. Here I'm going to go ahead and get rid of my constant by subtracting 22.5 from both sides, leaving me with negative 10.5 equals negative 1 5/10. Last but not least, get rid of the coefficient by dividing both sides by negative 1.5. And I'm left with 7 equals X, technically. That doesn't answer our question though, because the real question is, at what time will the two candles be the same height? Well, you probably forgot this, but they did give us this piece of information right here, that the candle was originally lit at 6 p.m. So 7 hours later would mean the candles would be at the same height at what time? It would be 1 a.m. because you're adding 7 hours onto 6 p.m. So I would say both candles will be the same length at 1 a.m. And there you have it. That's it. So hopefully you learned how to solve equations with variables on both sides, with word problems as well as written equations. Just please remember that if we do have variables on both sides, you can choose to move it to the left or to the right. There is no right or wrong direction in which you move things. Hopefully this lesson has helped you. Thank you so much for tuning in. Until next time, bye.